We have our application ready and running on localhost 3000. We have a backend server running in fast API. So we load a student from here, and these are the current metrics of the students, which are logged in the database. What if simulation is here? We can decrease the course score and see in real time that it affects the student's performance. Along with that, the recommendations are changed for him. Also, whatever the data was being suggested, whatever the course was being suggested, it will be shown that how much that course will be affected because of this. The features shift sensitivity is getting monitored. So this is one of the parts of the explainable AI of why did the expected success drop by 40% and why was dropout rate increased by 25%. So we can say that challenge level was decreased. And this is the plain language which is being derived by the model itself. We can have AI oversights. Along with that, we have some improvement ratings on where you can actually improve your performance. We have a casual inference graph where the red edges show that the edges connected, the vertices connected have negative correlation, and if they are green, it shows that they have a positive correlation. Now, the thickness of the edge shows how highly that change in feature 1 affects feature 2. So here is the casual tag. Then this is the LLM, which is getting this as a request body and outputting this as a response for any student. We have an instructor view where we can see where are the foundation gaps. We can again change it and it gets changed. Also, we have some concepts here which get changed accordingly. We can see who actually drives the derivation. So here engagement level was the one with the highest weight, then score, then comfort with difficulty, and then time spent. Here is the technical relevance of that. So this is pretty much it. We can actually load many students here. So for student 2, you can see that the inferred competencies have been changed for student 77 but not for student 42. This is because lack of data as of now. We have a data which is highly skewed and not following a proper distribution as of now because training takes time. So we can see the concepts for him are a bit better than what we saw for the last user. Also, if you see closely, we are caching our top recommendations so that the model knows which is the top K among the class, among the sample size of the population. And we have quality index of the model performance. Along with that, we have the stability guard, which will prevent it from overfitting. As of now, it's 100%, as it shows it is in its optimal condition. And it is this can should not be mistaken with the actual probability that 100% sure. It is not the accuracy, it's just the stability of catching true positives and true negatives among all the data points. Along with that, we have an SDK, XAI SDK, which can be used with any Python application via pip install. And basically, what it does is it imports the XAI SDK. And for this particular example, it is concept bottleneck example. It uses torch explainer, and let me show you the output. As we can see here, the top concept scores and top feature scores have been generated. It is derived from the learned data. Then for MLP, again we can see the stability score is of 0. So this is again for a very skewed data set. And the transformer attention. So we can see the correlations. And another technical aspect of why we are using transformer attention here, because the recommendation system which our app is based on is currently being inferred from a transformer pipeline, which is custom in-house knowledge.